All right. So let's continue this concept that if we take a look at a regular triangle, with green, if I work with the angle 60, opposite over hypotenuse is √3/2. But I could get the same √3/2 if I do cosine with 30 degrees, because that uses the same two sides. If I take this idea and I apply it to a, well, we can call it a unit circle, to the Cartesian plane, right? An angle of A, right, plus the angle of B needs to add up to 90 degrees, because you know that the inner angles of a triangle add up to 180, right? So angle A and angle B, we're going to call them correlated angles within a triangle. So far, so good. But at the same time, instead of using this other angle, I can say that same angle beta appears here. The angle to that same line, the same arm, if I make an angle with the y-axis this time, would you agree? Does that make sense? So if angle alpha was a 30, beta would be 60. If that was a 45, beta would be 45. If this was a 1, beta would be 89. Everyone okay so far? So these are correlated angles. And angle A makes an angle between the arm and the x-axis. Correlated angle is the angle arm with the y-axis. All right. Let's talk about the adjacent sides, the x and the y's. Remember, for this triangle, this y distance is the same as this y distance. And this x distance of the dotted triangle is the same as the x distance of the lower one. Maybe I should use some highlighters to make the difference, okay? Versus, where's my pink at? Okay. Again, let's establish some things we already know. With respect to angle A, what is the adjacent side? X. With respect to angle A, what's the opposite side? Y. And what is the hypotenuse? R. With respect to angle beta, angle B, what's the adjacent side? And then, next one? And then R. So what I wanted you to notice that I have to use another color because I don't want to confuse you. The adjacent side X and the opposite side X are exactly the same. In the same breath, can I figure out? Yes, there's my blue. The opposite side Y and the adjacent side is also Y. Right. So using this, I'm going to establish what I already did in the previous example. Sine of the opposite side of one side is the adjacent side of the correlated angle. And so if I do sine opposite over hypotenuse, the correlated angles adjacent over hypotenuse gives me the same angle. Therefore, I can say for any angle, sine of some angle is equal to cosine of 90 minus that. As an example, sine of some obscure angle, 10, is equal to cosine of 90 minus 10, which is 80. Right? Give me any angle between 0 and 90, and we can make this work. Even sine of 0. Sine of 0 degrees is the same as cosine of 90 minus a 0, which is cosine of 90. If you don't believe me, try it on the calculator. And this is why sine and cosine are correlated. I'll say it one more time. This is why sine is correlated to cosine. This is why secant might be correlated to cosecant. This is why tangent might be correlated to cotangent. There is a difference of that 90 degrees and you'll get the same thing. What do I mean by that? Take a look. Okay, sine is related to cosine. Sorry, sine of an angle and cosine of a correlated angle are equal to each other. So you can say sine and cosine, right? They're the same as long as the angles are correlated. Tangent and cotangent, they have the same answer if you're using correlated angles. Yes, absolutely. And secant and cosecant are gonna have the same answer if you use correlated angles. And it's all simply a difference of 90 degrees. So I want you to just notice this strictly from using a calculator. All right. Once you have this copied, I'd like everyone to turn to the back of the page and you will see a chart. And you could do it in groups of 2, you could do it in groups of 3, you can do it in how many people are in your row right now. I would like you to bust out your calculators. One person, I would like you to literally calculate every single value in column 1. And your partner or whoever's in your group will calculate all the values in column 2. And I would like you to compare them. Notice how, right here, decimals and all. So I'll do the first one for you, okay? Emiche, sine 20, please. 0.342, that's good enough. Yeah, that's good enough. And then cosine 70. 420, so on and so forth. Okay. Why? Sine and cosine, they are using correlated angles, so their answer is exactly the same. Before you go on, the exercise also asks you to use correlated radian angles. Does anyone know how to change? Do you know how to change your calculator to radians? No? Let me try to explain. It depends on your calculator, but oh man, you got one that my parents would use.
Yeah, that used to be my dad.
Yeah, it takes me back. It's actually making me a little emotional. Oh my gosh. I remember seeing this in my dad's office when I was a kid. When I was like, yo, what is that? Because back then there were no real computers back when I was a kid. Oh my goodness. Okay, woo! Okay, woo, okay, radians. Yes. Oh. I'm trying to figure out if you can do radians here. There must be a way. Honestly, I'm not quite sure. Or
Yeah, I don't know.
this is it's more of a, well, it still says scientific calculation. There must be a way to do radians.
Yeah, and it says degree on the
Yeah.
bottom, so that means.
I might have to look up a manual for you. But yeah, for now, you might have to just change it to degrees. Can you get to degrees?
Which one is?
Secant. Secant is 1 over cosine. So solve it in cosine and then do 1 divided by. If you're wondering how to do secant and cosecant, take a look here. It asks you to do the same thing for cotangent. Just do 1 over tangent. Okay. Who needs some help with radians versus?
Why would it work? Like I can really.
If you plug in radians, pi divided by 11 is 3.14 divided by 11. It's like you're putting, so 3.14 divided by 11 is like 0. Let's say 4. It's like you put in an angle. It's sine of 0.4 degree. It doesn't know that it's radian. You have to change. Well, it's up with radian. Yeah, I'll be right there. We need to.
No, only the ones that are in reading. So like the last 2.
Yes, you can do that. Yeah.
Wait, degree?
Cos bracket.
Oh my God, I changed it. I pressed it.
Sine of that. Sorry, cosine of. Yes. No, sorry, no, not that. So 180. The pi and pi is sort of 189. 16. Yeah. Final the answer. Final the answer. That answer got the same number in the last. Right. So we did it right now it's 3. Degree. I want to keep this high thing. It's set up. And then you can actually plug in both sides of bracket 9 times I divided by.
Jordan Love is going to be.
When you are given a angle,
Yeah.
you actually have to change it to radian mode. Because think about it this way. Right now, you told the computer the angle is 4. Right now, pi over 11 is 4.0. If you put this in the sign, it's like it's telling the computer, hey, my angle is this. So it gets confused.
Yeah.
Correct. You can change that to degrees, which is 100.
Oh, I didn't. Wow. Why would you? Wow.
Is degrees and radians again. That is the radian. Sine, bracket.
Then we'll turn it back to 10:25. No, I made them.
Cotangent is same as 1 What's the ratio for that's it. So if the angle is in radians, you need to change your calculation to radians, or you gotta change that to a degree. Either way. What do you think you're gonna do? You think you're gonna change the angle?
Well, I don't know. Well, one, there's no line.
So.
So you, well, think about it this way. Right now, you're on the computer thinking 61 degrees. What's pi over 11? Pi for 11 is 0.28. You're telling me that your angle is 0.28.
And
Right? So if it's in radians, it uses a completely different thing. Your total is 6.
but that only applies to only you're gonna find
Correct. So you see that it's in applied, you clearly see it's radians. Remote. We're reading mind you, yes, sine of pi your angle. Remember 0.3. If I did this in degrees, sine of pi.
No, I didn't get it.
You have to make sure either this is in degrees or in a degree.
Oh.
Right?
Yep.
Yeah, sure.
It should be the same one.
Sure.
How do we do it? So. Oh, shit. So, I think. Why would I go?
Oh, yeah.
Correct. You have to do. Most calculators, they do tan 79. There. The way this calculator works is you're putting in 1 divided by 76 tangent. So it does a tangent and then it does 1 divided by. So the calculator is just doing what you plug in. ERG, if you press it once, it turns into RAG. And then that's again, it turns into a third that you don't need to know. You just do DEG and then Good.
All right. That was a long silent recording. If anyone's watching this video, then you're gonna have to skip a big chunk of time here. So I'm hoping we've established the fact that if we have correlated angles, I'm gonna call it a correlated ratios, I suppose, are going to have the same value. They're going to equal, right? So if sine is a theta, cosine would be 90 minus theta, whatever that case may be. It is a difference of 90 degrees. Why does this help us? Well, right now, it doesn't quite help us because you could still use a grade 11 way. And some of you might be very tempted to still do the grade 11 way. So I'm going to show you what grade 11 might look like here. And then I'm going to show you what using correlated angles might look like. All right, let's do it the correlated way. Just in case you forget what these angles mean, it is sine 90 minus pi over 3 is 60. Just like Cass rule, I hope that it becomes a natural thing because you're going to have to either memorize all that or understand how it works. So just like Cass rule, you know how there's a positive and negative? Either you memorize all 12 or you know where it comes from. It's going to be the exact same thing and you'll get there. It is a logical flow. So grade 11, you can just plug in. You can do 90 minus 60 in your head. I know you can, right? And so let's solve it. Sine 30 using special triangles. The answer is 1 over 2. Correlated angles, sine of 90 minus 60, noticing that it is, a difference of 60, we can rewrite this as cosine of just 60. Remember, sine of 30, cosine of 60 are correlated. So if you see a difference of angles from 90 degrees, that's a clear signal that, or that's an indication that, maybe it might be helpful, maybe it'd be easier if you convert to its correlated ratio. And cosine of 60 using special triangles, 1 over 2. Now, I know this is obviously easier, but I'd like you to try to do both methods so that you'll get used to what correlated means. Be comfortable with changing the angle by finding a difference of 9 from 90, okay, for the other two. Let's try this one. Harpy. Yes, Jamie. Yes.
Are you going to teach us how to do it without
No, it's just these radians. So here, how about this? Without converting, this is cosine of, sorry, that's just, never mind. Yeah, pi over 2 minus pi over 4. If you just solve it, fractions in your head, that is the same as just pi over 4, right? Because remember, this is 2 pi over 4 minus pi over 4. Fractions. And so pi over 4, cosine of pi over 4 is equal to root 2 over 2. Or of course, if you're using special triangles, know that it's one and the same. I like that one though. In the same way, you notice that cosine of pi over 2 minus pi over 4, 90 minus 45, is the same as this angle for sine. You remember how 90 minus 60 is the same as just regular 60 of the correlated? That's what I'm talking about. You're looking at that last bit, and you know that's what the angle is. And this is equal to, of course, the same answer because 45 degrees, that's what you get. Yes.
So in the second step, after you do the fraction stuff, radians,
Mhm.
you convert the pi over 4 to degrees in order to express the time.
Yes, just to show you that don't be afraid of seeing fractions, it's just angles.
Yeah.
I wanted people to see that all the exercises they've done so far, it's literally the same thing. When I give you an angle such as this, that's what it means. And so you can switch it.
So you have to convert to degrees you want.
No, you can leave it to radians if you feel comfortable using radians.
So once you got pi over 4, you need to find that as an angle in order to express the time.
No, I mean, the special triangles can be written as radians. I think I remember when we did 4.1 together, I wrote both angles. They're interchangeable.
Is there any value?
The only value in using radians for these questions is to be that much more comfortable with it. Because if you take this to, let's say, university, there may be questions where we work strictly based on distances, like arc length. Right? So that all the terminologies, all the questions, all the measurements are given in radians. And you should know generally what each of those fractions mean. Oh, I know you can do this in grade 11 methods, but if I wanted to convert this right away, 90 minus something, I don't even care what that something is. I can rewrite this with its correlated ratio as pi over 6, right? This is what I'm looking for right here, right there, pi over 6. That, of course, is the same as and using special triangles, I'm pretty sure you can figure it out yourself. Give yourself a minute to do so. Your final answer should be √3/1. So figure this out. Use special triangles.
Why'd you write it all the way? Why'd you write that
On the
other side?
oh, because this is how we use correlated angles. There's that little thing. I just didn't do the grade 11 way because, yeah, I got lazy. Question? Becky? No?
I know how to do it.
Excellent. Okay, everyone. Let's see. I didn't really give you too many. Yeah, as practice.
So that's the end of our lesson for today.
I'll say it one more time. It's the end. What I'm going to do is take a look at some of the homework questions I assigned, but you're not ready for every question. I'm going to give you only what you can handle, just like these, all the angles within 90 degrees. In other words, all the angles here. Does that look familiar to everyone? 90 minus some angle for sine is the same as cosine of that angle. Cosine 90 minus some angle is equal to sine of that same angle, so on and so forth. Tan and cotangent, they are correlated. Cosecant, secant, they're correlated. Secant, cosecant, again, you get what I'm saying. All the questions I'm going to give you are going to involve just quadrant 1. Get so comfortable with it that I don't need to talk about it tomorrow. I'm going to show you how this concept will transfer over to the other 3 so that you don't have to memorize 12 different things, but you understand where it comes from and you just do it on the fly. All right. Okay, give me a second. Questions I would like you to try for homework. It's 90, 90, 90. Nope, not 90, not 90. So numbers 1 and 2 work, given that this pi over 7 is definitely small. Okay, the first expressed as a difference between the covariant determinant. Number 5, 4 over 8, 5 and 6, as well as 3 over 11 is definitely. Oh, I can't ask you that just yet. (9a, 10a). Yeah, let's leave it at that. Numbers 1, 2, 5, 6, 9a, 10a. So basically 6 questions that use correlated angles from 0 to 90 degrees. Please, again, your goal is to be so comfortable with this, I don't have to talk about it tomorrow, that you understand that a relationship of 90 degrees is all you have to watch out for. And then I will show you how that understanding applies to anything after 90 degrees. Any questions? All right, I'll pause here. The rest of the time that you have in class, please use it as you see fit. And I do see you tomorrow, right? Tomorrow's our last day of the week, unless you're here for Critter Rescue, which if you do, I'm sorry, it sucks. But anyways.